Hello everybody, this is Dr. Hussein back to math, and this is level 2 semester 1 math, third math in faculty of engineering. As you remember, we already studied math 1000 mathematical foundation in semester 1 level 1, and in semester 2 level 1 we studied calculus and linear algebra. Now we will continue and talk about calculus and statistics. This course, this semester, we will gonna talk about 5 topics. These topics are sequence series regression, the first topic. The second topic is data presentation and the statistics. The third topic is the probability, and the fourth topic will be Laplace transform, and the fifth or last topic will be partial differential equations. Now let's focus on the first part, which is the arithmetic, let me say the series sequence and progression, and we will cover it in a few let me say lectures. This part is linked to the first course learning outcome, which is identify different type of series and test their convergence. Okay, now we will go through the definitions for sequence, series, arithmetic progression examples and applications. This is what we are going to talk today in this lecture. Now, first of all these title, sequence, series, regression, talking about set of numbers, and these numbers are linked in a uniform way. So it make, let me say, a pattern. As example, if you look to the number to the left hand side, top left hand side of this slide, 2, 4, 6, 8, 10, 12, 14, we can see that there is link between this number. What is the link? We adding 2. 2 plus 2, 4, plus 2, 6, plus 2, 8, and so on. If we look to the right hand side, top right hand side of this slide, we can see 1, 3, 6, 10, 15. We can see it's the same shape, okay, rectangular shape, but sorry, triangle shape, but it's increased, boost. Look to the next shape or next shape, money shape, or all these shapes, there is link. We can see there is a pattern, okay, we can follow. This is useful. I will talk about the application at the end of this lecture. Now let me start with definition. I will define sequence. Sequence is a set of number. By the way, all of them set of numbers, series, sequence, progression, arranged in definite order according to some rules is called sequence. It means a set of numbers, there is a link between them, and we separate them by comma. As example, 4, 7, 10, 13, 16, the first example here. You can see that we're adding 3. 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13, and so on. So there is link. Or let me say the second one, 2, 6, 18, 54. We are multiplying each item by 3 to get the second next item. As example, 2 by 3, 6, 6 by 3, 18, 18 by 3, 54, and so on. Another example, 5, 3, 1, minus 1, minus 3. We can see that we are subtracting the number and the preceding one. As example, 3 minus 5, okay? 1, which will give minus 2. 1 minus 3, minus 2. Minus 1, minus 1, minus 2, and so on. So there is link between them. There is pattern we can follow and use it somehow, as I will explain at the end with the applications. Now the second item or term to be defined is series. Series is the algebraic sum of the terms of a sequence or a progression. So again, it's set of numbers linked somehow. It's a sequence. But rather than we separate numbers by comma, we will add them. I mean, some of them. Some 4 plus 7 plus 10, rather than 7, 4, 7, 10, comma. So you can see these 3 examples. We are adding the numbers. Okay. Now we can sum the numbers up to specific value. As example, if I want to sum all n items in the sequence or the series, I will call it S. It means sum. Sn, it means sum up to n. If I want to add only the second 2 items, I will say S2. It means up to 2 items. S7 up to 7 items. S11 up to 11 items, and so on. So sum is adding numbers up to specific value. Now arithmetic progression, let's define it, is a sequence of number such that the difference of any 2 successive numbers is a constant. It could, by the way, it could be sequence or series here. So again, this particular sequence, the difference of any two successive number should be constant. As example, 1, 2, 3, 4 is a sequence. Okay, we call it arithmetic sequence or progression. Why? Because the difference between any successive number is 1. You can see here the 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1. So always the difference between any two numbers, close numbers, will be 1. The second example, the sequence 3, 5, 7, 9, 11, we can see the difference is 2, because if we take the second item, which is 5, minus the first item, which is 3, it will give 2. 7 minus 5, 2. 9 minus 7, 2. 11 minus 9, 2. So I continue. You see, the difference is the same. Okay. Now, next, third, let me say example is, you can see 10 minus 20 minus 10. 0 minus 10 minus 10. Minus 10 minus 0 minus 10, and so on. So the difference here is minus 10. All these examples, we call them arithmetic progression. By the way, it's a progression, but we define it to be arithmetic. Does this mean there is other, let me say, type of progression? Yes, there is. Okay. Now, you can see here examples, more examples. Here, this example, 0, 2, 4, 6, 8, 10, 12, 14. We are adding 2. So 0 plus 2, 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. You see, there is pattern we can follow. This is the arithmetic progression. So the difference is the same. We have constant change, okay? Just adding. If we know the first item, just add the difference. Every time you add the difference, you go the arithmetic progression. More examples about arithmetic progression. The first one is 20, 30, 40, 50, 60, 70. So it seems to be the difference between them is 10, because we add 10 to 20 to become 30. 30 plus 10, 40. 40 plus 10, 50. 50 plus 10, 60. 60 plus 10, 70. The second example is 17, 20, 23, 26. Oh, it's clear. If I subtract 20 minus 17, it gives me 3. So it means I'm adding a 3. 23 minus 20, it means 3. So you see the difference is the same. Now my question here, if the difference is not the same, we will not say this is arithmetic progression. Okay? This is not a progression. The different arithmetic progression, it should have the same difference. Okay. 40, the third example, 41 minus 48, it gives me minus 7. 34 minus 41, minus 7. 27 minus 34, minus 7, and so on. So this is arithmetic progression. Some other series progressions, okay, example is 1, 2, 4, 7, 11, 16. By the way, I gave you here directly what is the pattern, okay, but how we get it, this is to explain later on. But have a look here. 2 minus 1, 2 minus 1 is 1. Now let me go. 4 minus 2 is 2. Oh, it's different. It seems to be, it is different. So it is, D is not the same. So this is not arithmetic progression. But what we say, see, have a look, what is the pattern here? If we add 1 to the first item, it will become 2. 2 to the second item, to become 4. 3 to the third item, to become 7, and so on. You see? Now let's go to the second example. 3, 6, 12, 24. The pattern here is we are doubling. 3 plus 3, 6. 6 plus 6, 12. 12 plus 12, 12, 24, and so on. The next item, 0.52, 3.55, 6.58. Okay. If I subtract 2 minus 0.5, it gives me 1.5. 3.5 minus 2, 1.5, and so on. So the difference between any successive numbers is 1.5, which tell me that this is arithmetic progression. 4 minus 7, the last example. 4 minus 7 minus 3. 1 minus 4 minus 3. Minus 1, 2 minus 1 minus 3. Oh, the difference is minus 3. So this is arithmetic progression. Now more example on arithmetic progression. Which of the following, first let's see how we can know that this is arithmetic or not arithmetic progression. Example 1. Which of the following sequences are in arithmetic progression? I, double I, triple I, and IV. Okay, let's take them one by one. Now, the first progression is 2, 6, 10, 14. So I will find difference between each two numbers. 6 minus 2, 4. 10 minus 6, 4. 14 minus 10, 4. Oh, so the common difference, D, is the same, which is 4. So I can conclude here that this is arithmetic progression. Let's go to the next example, which is 15, 12, 9, 6. Okay, 12 minus 15 minus 3. 9 minus 12 minus 3. 6 minus 9 minus 3. Oh, the difference here is the same, which is minus 3. So we say this is an arithmetic progression. Example number 3. 5, 9, 12, 18. 9 minus 4, minus 5, sorry, 4. 12 minus 9, 3. 18 minus 12, 6. This is an non-arithmetic, is not arithmetic progression because difference is not the same. 4, 3, 6 is not the same. Last example, we have fractions here. Okay, so we can say here that 1 over 3 minus 1 over 2 give me 1 over 6. 1 over 4 minus 1 over 3 give me 1 over 12. So it is not the same. So we say this is not an arithmetic progression. Now, after we know how to make sure that this is arithmetic or not arithmetic progression, let's come to the formula used to represent arithmetic progression. Have a look. If we have progression, the first item of the progression, we call it A. This is the first item. It means item number 1. And the difference between any successive items is D. This is the difference. T, we use it for difference. And N is the number of items within this progression. Okay? Then we can say that the nth item, its value, equal to A, which is the first item, plus N minus 1. N is the items numbers or the item position. And D is the common difference. Let's apply it in example. Have a look. He told me find the 7th term of the arithmetic progression 2, 6, 4, 10, 40. First of all, he told me this is arithmetic progression. I don't need to check. But just to show you, 6 minus 2, 4, 10 minus 6, 4. So this is arithmetic because the difference is 4. Now I know D is 4. I know the first item, which is 2 here, A is 2. And he asked me to find the 7th term. The 7th term, its value. You have formula now, where A, this is the formula. Okay? A is 2. 7th item, it means N is 7. And difference D is 4. Then I substitute and I do the math. The value will be 26. You see, very easy. You substitute in the equation and then to find the unknown. Also, it's not only we have formula to find the item within a progression. We can find also the sum of up to specific item. Now, sum of the we can use the sum S for sum of the first number, okay, of an arithmetic progression. S is 1 over 2A plus AN multiplied by N. Now, if we look to find sum up to N value, okay, then we have this formula. Now, let's say this is the general formula. What it say? It says Sn, it means the sum up to N value, equal N over 2 multiplied by, between brackets, 2A plus N minus 1D. Okay. Let's use it in example. Have a look. He told me find the sum of the first 10 numbers. So he wants me to find S10. S10, it means up to 10 numbers. Sum up to 10 numbers of arithmetic series. He told me that this is arithmetic series or sequence, by the way. 1, 11, 21, 31. I know first this is arithmetic progression. Do I have formula to find the sum? Yes, I have. Now the difference, it's clear. 11 minus 1, 10, 21 minus 11, 10, and so on. So difference is 10. The first item is 1. Also, it's taken from the progression. Now let's go to find S up to 10 items. So we will say S10. Now what's it say the formula? N over 2, 2a plus n minus 1 multiplied by d. N is 10, a is 1, d is 10. So I substitute and do the math. I got Sn equal 460. These are few exercises about what we discussed. I advise you to solve it, and we will solve it in details in the class. Okay, arithmetic progression. More examples. Now we have two formula. Don't forget formula. The first formula is to find the value of the nth item of the progression, arithmetic progression, and the second formula is to find the sum Sn up to specific item, which is n. Now example number 1. Determine the number of the term whose value 22 in the series 2.54, 5.57. Now in this example, he did not tell me that this is arithmetic progression. And as I mentioned, there is other progression. So I need to check. So let's make sure it is arithmetic progression. I will come to check 2.5, because if it is arithmetic progression, then this means that we can use the formula. Now 4 minus 2.5, 1.5. 5.5 minus 4, 1.5. 7 minus 5.5, 1.5. So the difference is 1.5. And also I know the first item A, which is 2.5. It's also given in the question. And he told me that the term equal 22. I wanted to find its place. What is its place? I mean, you know that each item have position or a place within the progression and have a value. He told me the value. Now it's like opposite. He asked me to find its position. Then I come to the formula. I know nth equal a plus n minus 1 times d. I have a, I have d, I have the nth itself. Then I substitute, as you can see, and I do the math. I found that the position will be 14. So item number 14 in this arithmetic progression, its value is 22. Another example. Find the sum. Now he asked me now about the sum of the first 12. It means S12. I mean, he wants me to find S12 of the series. First of all, let's make sure that this is arithmetic progression. 9 minus 5, 4. 13 minus 9, 4. 17 minus 13, 4. So difference is 4. The first item is clear 5. And he wants me to find 12, Sn, S number 12. So n is 12. I have formula. Then I just need to substitute 12 over 2, 2 by 5, 12 minus 1 by 4. Do the math. Then the sum of 12 item of this arithmetic progression equal to 324. Another example. Three numbers. You see, I'm giving here different ideas how we deal with arithmetic progression. Three numbers are in arithmetic progression. Their sum is 15 and their product is 80. Determine the three numbers. He told me about three numbers in arithmetic progression, so I know the formula for arithmetic progression are apply here, the two formula. And also he told me their sum and their product. Okay, I will come. Let me assume the items are A and A minus D and A plus D, because the difference between them D, right? If I assume that the item is A, then the previous item is A minus D and the next item is A plus D. This is the definition of arithmetic progression. So if you can see here, I add them. A minus D plus A plus D equal 15, as he told me in the question. The sum is 15. You can see D will be cancelled here. Minus D plus D will be cancelled. So what is left? A plus A plus A, which is 3A, equal 15. We got A. So from the first information, piece of information he gave me in the example, I got A. Okay, I come to the next piece of information, which is their product is 80. It means A multiplied by A minus D multiplied by A plus D equal 80. Just a minute, A minus D, A plus D, this is complete square. So I can write it A square minus D square. And since I got A from the previous information, then I substitute by 5 here and here. See this equation? One equation with one unknown, easy to solve. So we go through math until we get D equal 3. So I have D, I have A. Let's back and substitute here with the assumption we started with, A minus D, A plus D. We got the numbers 2, 5, 8. Another example. Find the sum of the numbers between 0 and 207, which are exactly divisible by 3. Now have a look here. The series from 0 to 207, okay, but all numbers are divisible by 3. It means except to be divided by 3. So if I come 0 divided by 3, 0, it's not accepting divide by 3. 1 over 3, it will not be an integer number, it means 2 over 3, not acceptable. 3 over 3, yeah, it will give 1. So numbers accepting to be divided by 3 without reminder, then this means that these are the item in this progression. So I will say the item or the series is 3 plus 3, 6, 9, and it means divided except to divide it by 3 until 207. Now back again to the question. He say find the sum of all the numbers between 0 and 207. Okay, now I defined the arithmetic, now the progression, and see this is an arithmetic progression because the difference between them is 3 between numbers, and the first item is 3. Okay, so the last term in this arithmetic progression is 207. So he gave it to me as a piece of information. I will use A and D to find how many items in this progression. So A plus n minus 1 times D equal 207. I have A, which is a 3. I have D, which is also a 3. Then I substitute and solve. I found number of items is 69. Now, next, back to the question. He told me find the sum of all numbers. Just I've been looking for n. Since I got n, I have A, I have D, I have formula. So S69, it means the sum of all items of this arithmetic progression equal to n, which is 69 over 2 multiplied by 2a. A is 3 plus 69 minus 1, which is n minus 1, times D, which is 3. Do the math, we got the sum to be 7245. Another example. He told me that the first 12 and last term of an arithmetic progression, 4, 31.5 and 376.5 respectively. So he gave me specific item, their values. The first, the 12, the last. The first part, he asked me to determine the number of terms in the series. Okay. Number of terms. How many terms? How many n? Okay. Step number 1, this is arithmetic progression, and the difference between n to successive will be D numbers. So if the first item is A, the second item is A plus D, the third item A plus 2D, and so on. And he told me in the question, the first item is 4. So he gave me 4. Okay. Also he told me the 12 item number 12. It means when n12 equal to 31.5. So I will say A plus 12, A, don't forget it's 4, minus 1, D equal 31.5. So this equation, we have only one unknown, which is D. We do the math, we do the calculation to get D. D found to be 2.5. So don't forget we have A, and we have D. These are two important elements we need to do the calculation. Back again to what he asked me to do. Find the number of terms in the series. Okay, I have A, I have D. Also, let me see what information he gave me. The last term, its value is 376.5. Okay, so let's find its position. I will say, okay, 4 plus n minus 1 times 2.5, which is D, equal 376.5. One formula, one equation with one unknown, which is n. We do the math, we find its position. 149, okay, plus 1, because minus 1 from the left hand side go to the right hand side, so n equal 150. This tells me that this arithmetic progression have 150 items. Okay. Now next he asked me to find the sum of all terms and the 80 term. Now let's go for sum of all terms. We have formula, say Sn equal n over 2 2a plus n minus 1d. We have n 150, we have a 4, we have d 2.5, so we just need to substitute and do the calculation. My advice here, when you do the calculation, because you have many terms, many operation, work in steps. Don't jump, step by step, otherwise you get wrong answer. And this is from experience. I saw my students, they know the procedure and they know the formula and they know how to do my calculation, but because they jump steps and do the calculation without looking to the operation and the proceeding of them, they get wrong answer. Now last part of this example is the 80th term is given. He wants me to find it. So a plus n minus 1d. Now a, I have it, which is 4. D, I have it, which is 2.5. And he asked me to find the 80th term, its value. So n is 80. So substitute and do the calculation, we got 201.5. Now, as application for arithmetic progression, you can see here, this is theater I in the Harvard University, and you can see that the first row, the difference between the first and second row and third row and fourth row is 10. It means 10 seats in the first row, as example. The second row is 10 plus 10, 20, and so on. Another example, stairs constructions. You can see here the stair construction in the main stair in front of the main building in Sohar University. You can see that the stair diameter here, or let me say width is 5 meters, the first stair, and the second one is 4 meters, the third one is 3 meters, and is gate narrow and narrow. Another example, Oman population, okay. In 2000, you can see here 2018, 19, 20, 21, and the prediction for 2022. And these are the values in million, okay? Now, if we have, you can see here, almost the bar chart here is uniform. It seems to be, it's increase in almost the same percentage. Now, if we want to predict the future, to see as example in 2040, what is the number of population of Oman if we go in the same way, because we can see that there is link, there is a pattern here. Okay, this will be great because it will be useful information. Why? Because we can estimate how much electricity, water, waste produce, food, anything else. We can predict it if we know the total number. So progression, arithmetic progression is useful because it's predict the future, predict something to happen later on. Okay, and based on this pattern we can predict. These are more exercises I advise you to solve, and we will solve them in details in the class. Okay, see you next lecture. Bye bye. Thank you.